Welcome to Brain Vision.
Okay, so we know since there's only one inlet and one exit, so m dot in should be equal to m dot out. If we expand it, we'll have m1 dot plus m2 dot is equal to m3 dot. So m1 dot is the mass flow rate for the water, m2 dot is the mass flow rate for the water vapor, and m3 dot is the mass flow rate for the mixture. So we know in this case, m1 dot should be equal to m2 dot since both of them are water, and so eventually we'll have 2m1 dot is equal to m3 dot. So now let's apply the energy balance equation, which is E dot in equal to E dot out, since the rate of change in internal energy, kinetic energy, and the potential energy is 0. If we expand it, we'll have m1 dot times h1 plus m2 dot times h2 is equal to m3 dot times h3. H1 is the enthalpy for the water, H2 is the enthalpy for the water vapor, and H3 here is the enthalpy for the mixture. So remember, m3 is equal to m1 dot, and the m1 dot is equal to m2 dot. So therefore, we can substitute with the m1 dot on each side. So eventually, the m1 dot can be cancelled out. So we'll have h1 plus h2 is equal to 2h3. So now let's use the saturated water table. So at 65 degree Fahrenheit, we'll have the enthalpy for the water is 33.08 British thermal unit per pound mass. And then at 20 psia, we'll have the enthalpy for the water vapor is 1,156.02 British thermal unit per pound mass. And now we can use the value here, substitute back to the equation to calculate the enthalpy for the mixture, which is H3 here. So eventually we have the H3 is equal to 594.55 British thermal units per pound mass, okay, which is the enthalpy for the mixture. So now let's assume the mixture's pressure is also at 20 psia. So now if we take a look at the table, we'll have enthalpy for the saturated water, which is H3F here, is equal to 196.27 British thermal units per pound mass. And the enthalpy for the evaporation is H3FG here, which is 959.93 British thermal units per pound mass. Now we can determine the quality of exiting string. Okay, so we have H3 is equal to H3F plus X times H3FG. So eventually we have the quality of the exiting string is equal to H3 minus H3F over H3FG. If we plug in the values, eventually we'll have the quality is equal to 0.415. And also based on the table, we'll have the saturated temperature at 20 psia, which is 227.92 degree Fahrenheit. And this is also the temperature for the mixture, okay? So therefore, the temperature of the exiting string should be equal to 227.92 degree Fahrenheit, okay? And these are the answers for this question.